So without further ado, let's put our hands together and thank them for coming, and go take it away, guys.
Okay, fantastic. Can you guys all hear me okay? All right, wonderful. Okay, first off, thank you so much for having us come and talk to you today. We're really excited about this. We put a lot of effort into this, and I think we're going to go through some really awesome topics today. As we're going through the slides, just as a heads up, if you have any questions, feel free to shout them out, raise your hand. Obviously, don't know all of your names, but we'll definitely call on you and whatnot. It's just easier when we have the slide up to answer a specific question as you see that content. But if you don't have any specific questions on the actual slides themselves, at the end of today's presentation, we are going to be taking a quick Q&A break. So if you have just general questions for either of us, that's a great time to go ahead and ask those. So with that, I just want to go ahead and go through a quick introduction, and I'm actually going to have Colin start us off.
Cool. Can you hear me?
Yeah.
Awesome. I'm Collins. I'm a senior data scientist at NM. And, I work on a lot of NLP projects. It's something I've always been interested in since, college. I think it's a pretty fun and interesting topic. Languages in general are very interesting, and figuring out how we can build rules around dealing with them and driving insights from them. So it kind of seeps its way into a lot of different domains. Anywhere there is language, there is the potential for an NLP project. So lots of different domains and specializations within the field. So with that, we're gonna kind of get into it, and I'll hand it off to.
Cool. So my name's Juli Hirt. I am a senior analytics engineer at Northwestern Mutual. And in my free time, I'm also a PhD student over at UW-Milwaukee in information science. I love NLP as an engineer. It adds so much value to our data, but the most important thing is it helps us pull data back in an easier manner. It makes it feel a little bit more natural. So we can just ask general questions of our data and get back what we want versus having to think about like a complex SQL query. So with that, I just want to quickly go through our goals and objectives for today. We've got 3 of them. First off, why and how is NLP used in the workplace? Second, what NLP methodologies are used in the workplace? And then finally, I'll wrap us up today with how is data prepared and stored for NLP work? So we'll touch a little bit on the engineering space as well too. But before we get into our main content for today, I just want to talk about the business impact of NLP and start to take a look at it more from an enterprise space than just the actual practice of NLP. So why are we interested in NLP in an enterprise space? Well, first off, it allows us to reduce human-dependent business processes. So a lot of the business processes we have at NM require some sort of approval. So someone has to go in, look at a form, at a video, at audio that we might be distributing, and say, am I okay with this, right? Well, there's 2 major issues with that. The first thing is time is a factor, and I think everybody in this room knows that time equals money. So the more time that we let elapse, the more money that we're losing, as well as the longer the review process takes, the more that review process costs us. Second, human effort is a bottleneck. So people can only do so much work in a week. So if we get a lot more documents or a lot more materials that need to be reviewed, that's going to take more people and more time. So we have to be cognizant of that. Next, we have the extraction of valuable non-structured textual data. So some of you in the room right now, I know are going through a non-structured data course. And obviously when we want to go ahead and touch on those objects that aren't traditionally data, so not like tabular storage, we want to crack those documents open, those images, those video, and pull that data out. The last thing is a top-down understanding of text collection. In order to have this conversation, I want to bring this quote up on the board here. Richard is a professional in the metadata space, and he stated that documents are knowledge artifacts that reflect the cultural milieu in which they arose. And what that means is those objects that we have within our enterprise space describe the strategy and objectives of our business. And to make sure that we're truly aligned with that strategy and objectives, we need to break those complex objects open and make sure that we're talking about the right stuff. So that's really what we're going to be focusing on today. And with that, I'm going to go ahead and transition to NLP in the workplace. I'm going to turn things over to Mr. Collins.
Awesome.
Of
Wait,
course.
What do I do with this?
You just click that like,
it.
yep.
Awesome. Yeah, thank you. So I think, kind of an interesting part that differs a lot from, what you encounter in school is, what NLP projects tend to look like in the working world or within a large organization. So I was going to kind of get into that and go over what some of the pipelines may look like and the different processes we use. So I know I personally would love to see the data set on the left. Yes, that's your left. Okay. It's, you know, it's great. It's super structured. It's really easy to drive insights from. Here we have a bunch of information on maybe like a patient. That's another thing is NLP is used pretty heavily in the medical field. So this would be kind of an example of that, where we have a lot of tabular information on a patient as well as their medical history, and answering some of the questions, maybe like what is the, you know, likelihood that this person will like what will be their disease progression based on their medical history. So at its heart, that's an NLP problem, and that's a hard question to answer. But what we see on the right is we actually don't have this tabular structure very often. In fact, we have a photocopy of a form that contains all that information, and it can be handwritten, it can be an image, it can be a PDF, it can be a lot of different things. But the main kind of thing I would want to emphasize is that as people that do NLP or practice NLP in the working world or in like within a large organization, it's really kind of up to us to extract the information and create the tables you see on the left so we can use them for downstream tasks. So with that, what do we need to extract information from these forms? This may be super familiar to y'all, but we use optical character recognition. The idea is on the left, we can see, that handwritten form, and then we pass it to a text detection algorithm. So you can kind of think of this as like a sliding window that goes over your image. That sliding window is a classifier. So it's going to say yes text, yes text, yes text, no text, and so on until we eventually get a bounding box for each line in our text. And from there, the job's not done. We have to segment the text. So identifying the separation points between characters. And then once we have those separation points and we have a hard divide on where a character begins and ends, then we can basically do a classification task. So given this input image of L, what is the appropriate Unicode or ASCII symbol that it corresponds to? So that would be like a multi-class classification problem. Okay, good. Got the M. So let's pan out and maybe kind of see what this looks like. So generally, you're not going to really have to build this yourself. It's kind of it's a general purpose pipeline, meaning that you're trying to find text in a document. So a lot of services provide this tool. And, in this image, we can see Amazon's kind of version of it. So, we have a form on the left with all of the text information and some bounding box information on the line level. And then on the right, we can see what the output of that looks like. So, I will say that a huge part of, your kind of like job within a company is going to be figuring out which service best suits your downstream problem. So there's different flavors of OCR. AWS has kind of highly specialized endpoints. So maybe you're interested in sentiment analysis or, different downstream tasks or, creating queries and things like that. So, AWS may work better for that. Azure also offers a different one. That's actually, I would say they have a more general purpose one. So, it helps you with the post-processing steps of restructuring the text, because you can see that, we've lost all structure about our table. So, picking the right service is a conversation that you have within the organization and developing a POC to figure out which one makes the most sense. And that's a huge part of it. So what does, an NLP pipeline look like in kind of abstract? We start with our photocopied form, and then we pass it to an OCR model, and then we do some post-processing on it. And the post-processing really depends on the downstream task. Maybe we want to preserve that table structure, so it's really up to us to recreate it. So the OCR gives us bounding boxes, so we know where each item of text is on the page, but we have to restructure that meaningfully for downstream tasks like document classification. A lot of things could go in this document classification bubble. It could be named entity recognition. It could be, it could be something more like layout specific. But the end kind of, or I guess the takeaway would be what you're left with once you've kind of gone through this process is something that is more structured. So we've extracted a lot of meaningful metadata, and we now kind of have a more tabular structure that we can work with and pass to like a model downstream. So, just kind of giving you the idea that, going through this process is really first about creating some structure that can help drive insights. Let's kind of go into what a specific business problem may look like. So here I'm focusing on the underlined one because it doesn't have any PI information. It's a marketing material. We can show you what the documents look like. But the business problem we want to answer is, what is the topic of a marketing material, and are the appropriate disclosures included? So like before, we don't actually have a nice table that we can just query and answer these insights with. We actually have a bunch of documents, the binaries for which are stored in S3. Juli has a great definition of S3 that blob storage, and you can kind of put anything in it. So this is something you're likely to kind of come across if you're not already familiar with it within an organization. But the idea is we don't have structured data. We have binaries to files. So how do we get the text out of it and start working with it? It's the next step. So what does some of these marketing materials look like? We can see that they all look pretty different. And this is a particularly challenging problem when you're trying to create structure from the output of an OCR model. So I think if there was a uniform structure and you were interested in extracting information from one of these materials, it could be as simple as just knowing the location on the page and grabbing things at that location. But when we don't have consistent layouts across our documents, but let's say all of them kind of have something in common that we want to encode, it's really kind of up to us to build out a robust solution that can extract what we're interested in. So maybe a good example would be I'm trying to think, what is like a billing statement or a bank statement? They all maybe have different questions and answers that are worded slightly differently, all in different locations on the page, and parsing everything into question and answer appropriately. And maybe doing named entity recognition to find out, like whose name's mentioned and stuff like that, is going to be, particularly challenging because there is no consistency and the wording is a little different. So you're probably going to have to leverage deep learning for that. So going off that, let's, the idea that these things are very different, and what can we infer that's true for all of these materials? So all of them have content, and all of them have, hopefully, disclosures. So that's kind of the theme that ties all of these very different layouts together. And what we kind of want to do is draw insights from the content and then answer questions about the disclosure that tie back to, okay, what is this thing about, and are the appropriate disclosures included? So what we can do is use the content region on these materials to do something like topic modeling. I'm sure you can come up with maybe more like kind of deep learning approaches to this, but this kind of helps us answer questions. Like if we do topic modeling, we can get an idea about what a submission's about. And topic modeling is essentially like a dimensionality reduction problem. So we don't care about word order. We have our count vectors or TF-IDF vectors, and then we basically transform it to a lower dimensional representation. And what we find is when we do that, we can interpret that lower dimensional representation by the words that are most common for that dimension. So that can help us figure out things like, okay, this particular form is about disability. This particular form has a score for annuities, or for trying to think, maybe it's just like a generic flyer. So figuring out what the topic is from this content section can help us really understand what this form is about, or what this marketing material is about. And then for the second step, we can perform semantic search. So this would be a slightly more deep learning approach. We basically create paragraphs for each section on the page. And then we have pre-approved disclosures that we're expecting to see on the page. And then, we basically cast those paragraphs to semantic vectors, and then our known disclosures to semantic vectors. And then we can just cosine similarity and see how close they are to the pre-approved disclosures. So going through all of those steps, we start with a marketing material. We extract the text using OCR. We do some post-processing to, create bounding boxes for paragraphs. And then, our kind of pipeline forks. We do topic modeling on the content to figure out what it's about. And then we do disclosure scoring to figure out which disclosures are present. And then the end result of that, that could be the end of the project, because at the end of the day, we didn't have a structured data set at all. So maybe actually just, creating a tabular structure with appropriate metadata on a particular document might be valuable enough for the business process. But if not, now that our data is in kind of tabular form and we've extracted interesting things from it, we can use it for downstream tasks like modeling the risk of a submission not undergoing human review. So we started with this, form that, we didn't have any information on, and maybe it was a photocopy or an image. And now we've essentially passed it through the pipeline, and we actually have a ton of interesting metadata that we've extracted through this process. So we now know that this is about insurance products. It includes an investment disclosure, and then our downstream model predicted it to have a risk or complexity score of 4 out of 5. So this would help a reviewer drive some insights and figure out, okay, maybe we don't want to approve this without looking at it. Maybe we actually do want to, take a deep dive into this document and make sure everything's in order. It also just kind of helps them allocate their work according to, how much time they have. Like the bottom one is a flyer. We give it a risk score of 1. It has the appropriate disclosure. So do we really need to look at it? So that would kind of be, I think there's different ways that that this process can help increase operational efficiencies. But at the end of the day, I think one big part is actually creating this tabular structure and something that we can query and work with in a more manageable fashion than just having a binary to a bunch of documents. So engineering is a big piece of this, and working with engineers to figure out, okay, what kind of structure do we want to create? Is it tabular? Do we need it as a JSON? All sorts of things. So working very closely with engineers on this process is super important, and just kind of an inevitable part of doing NLP. So with that.
Wonderful. All right. So before we switch over to data engineering for NLP, and you've been warned I'm a pacer, so you're going to see me go running across the stage quite a few times. Any questions on any of the content that Collins just covered before we go any farther? Because we're going to switch to a little bit of a tangential topic. Just want to stop here real quick. Yeah.
For the students, so they have some more background. We talked a lot about disclosures. Can you speak a little bit, so from a business perspective, why does that, you forgot a disclosure? Why does that actually, who cares? Or maybe the only disclosure. So why does that matter?
That's kind of how I felt when I started. Big whoop. FINRA exists. They will fine you for things. Realistically, we might have a situation where we have maybe an FR who's trying to sell life insurance, and they're sending out forms to everyone, or flyers, or maybe emails, all sorts of different mediums that they can communicate through. And I'm sure a lot of people that are on YouTube and hearing about crypto, there's probably a lot of promissory investment language in a lot of those videos where it's think of a get rich quick scheme, and guaranteeing returns on investments when you just can't is a big problem. So looking for promissory language in these in these materials, making sure they don't mislead consumers, and then also making sure the consumer has a good understanding of the risks that they're taking on. So, we can't guarantee that, this product will offer returns. There's all sorts of kind of disclosures that are needed for different products. And the I guess, point of which is to not misinform and to kind of legally cover, our representation of a product. So that's why it's important. And if you don't do that, that can cause a lot of problems. And what was it, like Lashgate? That's a great example. Like, an appropriate disclosure would be like, I switched. Has anyone seen Lashgate?
Lashgate? Anyone? Okay. So it's the scandal about L'Oreal makeup, where they basically had a bunch of influencers go ahead and try this makeup, and they're like, whoa, oh my God, it's so amazing, this is fantastic. And in reality, they were using fake lashes, or they were overreacting, or using another product. And the only thing that called them out was a little tiny tag in the lower left-hand corner of the TikTok that said L'Oreal partner. And that's the kind of type of disclosure that we're talking about here. So.
Yeah, and I think in that, a real disclosure that would be needed so L'Oreal doesn't get sued would be like, I literally just did a hard cut to fake lashes.
Yes, exactly.
So yeah, they're important, and now there's a lawsuit. So yeah, hopefully that answers it.
Cool. Yeah.
Related question: how those disclosures are, put in their forms in the first place? Are they, created by humans, or is it automated?
Yeah, and so I think, there's a few kind of interesting caveats to that. So the FRs who, are the people who create marketing materials generally. We also have people that work at the home office that, create materials that we also, pass through this pipeline as well. But at the end of the day, honestly, Angela can probably speak to the full life cycle of disclosure, but there's probably like a spreadsheet where they have a ton of disclosures that have been communicated down from home office to them that they need to use for different materials. And, you can imagine like, okay, I'm at work and, there's like, we got this spreadsheet for disability insurance flyers, and it says use this disclosure, but the legal team that writes these things, they change them over time. So maybe it's outdated, or maybe no one communicated that you need it. So I think there's the possibility of a lot that kind of gets lost in translation, and also a lot of people will take liberty in writing their own stuff if they've been doing it long enough, and they'll kind of take a stab at it themselves and just kind of like write it themselves, which makes it a semantic search problem as opposed to just like, grabbing like a bag of words like TF-IDF vector and seeing how close it comes to that. We want to know how, like you can change a few words in it, right? But like, are they semantically similar? Do they mean the same thing? So that's kind of the intuition for going with a semantic search instead of just, looking at a bag of words approach.
Cool. Any other questions? All right, delightful. So we're going to transition over to data engineering for NLP. Now, why on earth are we talking about data engineering in a data science presentation? As Collins mentioned, data engineering is a key part of a data science pipeline. Why? A lot of the data science questions that you might be posed with right now is to build a model, get a result, and you're done, right? So in the example that Collins has been walking us through, this is a business process in which we are constantly getting new documents. Every single day, every single hour, every single minute, we're getting new documents that need to go out there. So this model can't run once. It has to run repeatedly, and we have to get results from it throughout the day, throughout the life cycle of the model. So that's where we come into play. And I joke around with Collins a lot about this, is what really are data engineers? Are we the cog that like turns the pipeline? I like to refer to ourselves as the sun, and everything revolves around us, but whatever. I like to photosynthesize things is what I like to say. So what we're going to talk about is the role that a data engineer plays within the organization, and specifically the benefits that we get of this like sort of bi-directional relationship between data engineering and data science. So some of this stuff might be a little bit new. So we're going to start right off at the ground floor. Why does data engineering matter? So data engineers within an enterprise are responsible for three primary things. The first thing is we need to strategically store data. So if we're working in a tabular format, rows and columns, we're picking databases. We're trying to figure out, what our table structure needs to look like, what our entity relationship needs to look like. In the case of that data being stored, we have to think about efficient access. for our data as well too. So to make sure that the right people are accessing the data, that there's views available for aggregated sort of workflows, and that our data scientists can get the metadata that they need to feed into the model. And finally, maintain accurate data, and this is the most painful part of the job. If you are working anywhere where you're dealing with customers, which is probably going to be most of the enterprises that you're looking at, what we need to do is across all of our systems have an accurate picture of who someone is. And this gets very, very difficult when customers have multiple points of entry within our systems. So someone could come in with, for example, I always use maiden names as an example because we see that a lot. Someone might come into a system with their maiden name, then they go ahead and get married and they come into another one of our systems with their married name. Now, how do we go ahead and bring those two records together and say, this is my golden record, this is who this individual is? It's a very, very big challenge. But you can also look at other things like people's addresses changing, people's phone numbers changing, people's emails changing. It's constant, and we need to know who they are and how to get a hold of them. We like to say that data engineering is the first step in a long process to ensure and increase the value of your data. I'm sure in many of your classes you've heard data is invaluable, data is the new business oil, and that is true. People don't want to pay to store data if we're not getting some sort of business value from that. So, what are we doing on a day-to-day basis outside of sitting in front of our computers and writing a whole ton of code? Our responsibility is to extract, transform, and store data. For those of you that have any sort of data engineering experience classes you may have taken in the past, you might know the term ETL, extract, transform, and load. That is sort of the process that we live by, is extracting data, finding sources, whether it's an API, whether it's internal data, whether we're looking at documents, cracking them open and stealing the data from them. Then we're transforming it, making sure it's clean, making sure it's in the format that we want. If we want tabular, if we want XML, if we want JSON. And then finally, making sure it has a proper home that the correct people have access to. Now, data engineering is getting harder every single day because the definition of data for all of us is changing. So before, we just thought of things as tabular. If we go in our way, way back machine to 1972, and we're all at IBM, and we're looking at the very first SQL server, we're thinking rows and columns. Everything is going to happen at a transactional level. But all of a sudden now, we're in 2023, I believe, yes. And people are looking at data and they're saying, well, video is data. Well, a document is data. Well, audio is data. Well, someone's email is data. And you're like, well, great, but how do I store any of this? And more importantly, how do I bring it back? How do I point people to that right thing? And so we have to start getting a little bit more strategic around how we can pull data out of these objects that aren't necessarily queryable. I can't do a select star and pull back a video or pull back an image unless we are strategic about it. And that's what it boils down to. But when we start thinking about modern data types, there are other things out there that we're going to be looking at in the future. It's not just image, it's not just video, it's not just documents. It's going to keep expanding. So, as I mentioned in the beginning, NLP and data engineering have this sort of cute bidirectional relationship where we're both just trying to take care of each other. Not only are engineers trying to make sure that those pipelines run every single day and that we're being as performant as possible and that our data scientists have everything they could possibly want to build their models. NLP also gives us something back, and that something is so important and so incredible, and every single day I wake up and I thank my data scientists for giving me the best data I can ask for. Does anybody want to take a stab at what they give us back that is so incredibly important? Anyone? Okay. The thing that is so incredibly important for us is metadata. We don't get metadata for free. When I get a document from the marketing materials, I know the name of the document, I know when it was created, I know the size of the document, I know the date it was uploaded, and that's it. I know nothing about it. And if you think about your own personal computers, how many of us out there have a file named final.doc and final1.doc? You are not alone. A majority of the people that submit files have some bizarre file name that has absolutely nothing to do with the document. So we can't go on that alone. And in fact, here's an example of a process that we typically help with and the space that metadata really, really shines. So our marketing department goes ahead and makes a strategy document, right, for 2023. And they decide to name it Mark 2023. Okay, is the person that made it named Mark? Is this his goals for 2023? Like, what's going on here? We have no idea. But this individual says, I'm going to go ahead and put this up into cloud storage. So as the example that Collins gave before, that was S3. S3 is a file store that can hold any type of file you give it, whether it's just regular data or whether it's complex things like a document or a video or an image. And they go ahead and put it up there. And then our end user comes along and says, man, where's the Q1 marketing strategy document? How do I find that, right? And now we could go ahead and try and email the marketing team and say, hey, where did that document go? Do you remember what it was named? Do you know what file path you put it in on? This is the most amount of time you're going to waste in this process, is trying to locate that and trying to figure out who made it. But if this person asks our cloud storage right now in this process, we can't answer it. If they don't have the file name, if they don't know if it's a Word doc, if it's a PDF, if it's a PowerPoint, we have no idea what it is, we can't point them to what they're actually looking for. So let's get a little bit smarter about this process. And let's go ahead and call our data science friends. So in this NLP space, I want you to put Collins' pipeline, okay? So just imagine that whole process of going to go get the documents, cracking them open, going through topic modeling, deciding, do I have a disclosure or not? So now we get the document, it comes in, Mark 2023, somebody wants to upload it to the cloud, but we say, wait, 1 second. I'm going to go ahead and put it through this NLP process. I'm going to understand what this document is truly about. I'm going to understand the features that are really in this document. Then what we do is we create a piece of JSON metadata. For those of us that aren't familiar with JSON, that is a key value store. So what we do is we can define in advance of pulling in this metadata what sort of fields we want in there. Now, participation again. What sort of things do we care about that we might want to put in there? Anybody want to throw anything out? Nothing's wrong, I'll tell you that. What are some things we can put in there? Yeah?
Like if it's an article, like the title of an article or author.
For sure, that's a really good call out. One of the things that Collins and I have been looking to very, very closely is identifying very important pieces of a document. We call them semantically significant items within our document. Titles, subject headings, right? What in general are they talking about from just those very distinct objects? Anybody else? Yeah?
Words that are frequent that are not stop words.
Yeah, that's a great one, right? And that also gets us kind of towards the idea of topic modeling. Can we identify some things? The nice thing about that is working with JSON, we have a dynamic structure. So we could have a really big JSON object or we could have a really small one. We can reflect the document without having to have a bunch of null fields like we see in a traditional relational database. Anything else you think we might want to store? Yeah?
When it was created or when it was last visited.
Yep. Last created, last visited, last updated. Who did those edits, right? We might also be interested in information about that person. What department are they from? Where were they when they created this? What state were they in? So we can, again, build that out as much as we want. Thank you for all those answers. That was really helpful. So once we get that JSON metadata with as many fields as we'd like to do, we go ahead and we upload both of those things, the JSON metadata and the file, side by side, living next to each other in cloud storage. Now what happens is our user comes in and says, hey, where's my marketing strategy document? Now we have those topics. We know it's about marketing. We know the person that created it's from the marketing department. So we can go ahead and return that as a potential answer to their question. Now this gets even deeper, and we're not going to touch on it today, of how do we rank those responses? How close are we to the query, right? And I'll give you some hints on this. We use a lot of cosine similarity, and we use this really, really cool technology called semantic hashing to make sure that our documents that we're returning are ranked in the correct order. So what I'm going to wrap up on today is looking back at Collins' pipeline and exactly the tasks that engineers have to do in order to enable our data science best friends. So first thing is extracting and gathering text. And if we map this back to the example Collins gave us of the marketing materials, the first thing that we have to do as engineers is identify targets. And what that means is when a new document comes in, we flag that document and say, hey, next time we run this model, this document's going into the model. We're also responsible for facilitating file conversion. One of the most annoying and painful parts of OCR is there are only 2 file types that OCR services accept: PDFs and JPEGs. Now, Most people don't submit PDFs. If you ask somebody in an enterprise workspace to convert a Word doc into a PDF, you're going to have a lot more questions than answers. So we do that on their behalf. So Word files, PowerPoints, we convert those into PDFs. If we have any other file type that's an image, we can just go ahead and send it on over. Then the last piece that we're responsible for in here is actually facilitating OCR. So once we have those documents identified, we go ahead and push it through the OCR service, and then we go ahead and format that response. Now, the response that Collins gets to see is really nice and well formatted and makes sense. The response that I get to see from the OCR service is chaos. I get individual words that come up, and I'm like, oh, great. And then I also get it at the line level. So what I can do is make a decision, is it going to be beneficial for Collins to work at the individual word level and get bombarded with thousands and thousands of words, or does it make more sense for him to operate at the line level? And for our use cases, we operate at the line level. Now for pre-processing and post-processing, two things that we're responsible for. The first one is optimizing the retrieval of OCR results. So going back to our previous step, I create this beautiful JSON object. At least in my mind, it's absolutely beautiful. But now I got to go put it somewhere, and I got to make sure that Collins can find it, right? That the model can find it, that the model knows what it's working on. So I got to start thinking about some things back to organizing data, right? So if you're familiar with primary keys, globally unique identifiers, that can go ahead and tie the original document back to this OCR. So we got to strategically think about that. We also have to strategically think about, do we want to maybe partition things? So we think about maybe, do we want to partition by date? Do we want to partition by the department from which this document came from? And all those decisions result in optimization. The final thing we have in our pre and post-processing is ensuring stability of complex compute environments. All right. Collins has been very demanding of us. No. His model requires the ability to use GPU drivers. So it is our responsibility to make sure some environment exists with the correct GPU, the correct driver availability. You got called out.
Whatever.
But we need to make all those considerations. So when we go and talk to our data scientists, we ask, what's your wish list? Okay, well, of this wish list of 10 items, I can make 3 of those things happen. And then they're able to design around that. The next thing in the modeling space, we have to consolidate and store our model results. Now, this can differ. Sometimes we have to think if we're loading into a downstream web application, we might be communicating directly with that. Otherwise, we might be building reports for our business users so they understand what our model is doing and what our model is recommending. So we have to go then to our data analysts and say, hey, what tool are you using? How do you want your data back? I have it in JSON. Oh no, we're using Power BI. Well, now we got to go ahead and make it into a table. Otherwise, your life is going to be very painful. Then we also need to ensure the stability of those compute environments over time, right? One of the things that we talked about at the beginning was, why does data engineering matter? We're this cog that keeps going. So it's really great if I build this awesome, complex environment with this GPU and these available drivers. But if those drivers only like waking up on Tuesdays because they don't like waking up on Mondays, that's a problem. And I have to make sure that the environment is resilient enough for it over time. Last piece, automation. This is all the engineering space. This is our bread and butter. First thing is connecting model results to business systems. Again, if we're feeding those downstream decisions, if we're automatically closing cases that open up during the review process, that's our responsibility. And the last piece is monitoring error levels. And there's 2 kind of segments to the monitoring error levels. First, we need to monitor error levels within the pipeline because it's our responsibility to make sure every day it turns on and keeps chugging, right? So if there's an error going on, if there's a library that's not loading, if there's a piece of code that kind of sucks and it just keeps erroring out, we need to make sure that we're aware of that. And we need to make sure that we're remedying that and the right people are on it. The second part of it is monitoring the error levels of our models. As our models exist over time, what we do is we look for drift. We train on very specific features, and it's based on, for our marketing materials, from 2019 to 2021. But if our strategy all of a sudden shifts, if we start talking about different things, if we introduce a new disclosure, we have to be aware of the impact to the model and the decisions that we're making. And with that, we're going to go ahead and transition into our goal review. So we did talk about a couple objectives for today. The first one that we talked about is NLP in the workplace, and I'll go ahead and turn this over to Collins.
Yeah, so I think, one interesting thing is that, generally extracting and formatting the data in a relevant way for downstream tasks is, arguably the most challenging and important part, because you're literally creating a data set or a table that can be queried that never existed. So really thinking through that process, making sure that your NLP methodology for extracting and organizing and restructuring the data you pull out of documents it informs how how the data is structured and how people can work with it. So sometimes a project just ends there, and you just need to extract it and format it, and that's really challenging, and it's a huge pipeline. But maybe that's just the end point, and now your business partners or whoever you're working with can now just interact with it in an application in a efficient way. So or now that it's tabular, you can actually model something different. So just knowing that maybe a project does just end with landing the data, but knowing that a lot of NLP goes into creating that table. So collaborating with engineers is super valuable. I have learned a lot from Juli about what makes sense, and maybe because of the structure of our data and what we've been able to extract, how do we want to store it, and how do we want our pipeline to run in an efficient way? What portions do we want to scale up compute on? What portions do we want to maybe just switch how we're storing the files to speed it up? It's a whole kind of ecosystem, and learning a lot about that ecosystem can help you make decisions, someone that builds NLP, projects or pipelines, to build out a project that makes sense for an engineer to work with.
Can I add on to that as well, too?
Yeah, for sure.
General tip that I always say in the engineering space is close your eyes and shut your mouth, because it'll make your ears open more. Just because you have some idea in the back of your mind as to this is how I want to do it, if I open my ears, I'm really going to hear the problem, and I'm going to really hear the asks, and it's going to change my design theory. But if you're running around the world with your mouth open with all these ideas, you're not going to make the best decision out there. And to Collins's point, the amount of things that I have learned from him is incredible. And I'm very, very thankful for that. And that is because you shut your eyes and you shut your mouth and you open your ears.
Yeah, and it's just interesting. I might be oh yeah, well, I could do it faster on a GPU, but thinking and panning out and being okay, well, the business user only needs it, to be populated by 8 a.m., right? And is it worth bumping up that resource and paying more? And talking to an engineer about when the data is being landed and loaded and how the pipeline works can help me, go from okay, yeah, it would be nice for me as I'm working on it to have a GPU, because then I don't have to wait around, but maybe I just use the GPU for the modeling portion, and then when we actually run the pipeline, we ditch it. And those conversations wouldn't exist if we didn't know what each other were working on.
Yep.
So yeah, the other part is very few clean machine learning problems out there. I think thinking about the whole kind of ecosystem, oh God, I could go on about this forever, but it's not just oh, your data's dirty. It's oh, your data doesn't really exist in a usable format. There's not this clean application that's landing all the fields that you need to, solve some problem. You actually, you have to deal with an image of text or something unexpected like that. And so that's, as far as a data perspective, that's what I mean by there's no clean machine learning problem. But also I think that you have to think about the whole life cycle of a machine learning problem too. It's there's very few problems that you can just truly step away from and can be you can just fully automate something. And I always think of the perfect ML example is predicting when your Uber driver is going to arrive, because that's called a natural label. The outcome is something that becomes known through the application, so we don't need a human to label that. It doesn't require anyone other than the application to track that data. And then every time you make a prediction on how long it'll take, and then your driver arrives, we know how wrong it was, and we can just continually retrain on the fly until we somewhat stabilize. So that problem you can truly just step away from. And very few data science projects actually fit that mold. but at the end of the day, like, don't overlook the fact that increasing operational efficiencies in some other way by like landing the data in the first place, building out an application that, people who have to, drudge through that data can interface with. I think it's, a lot of impactful ML projects, are kind of reading between the lines and not just like modeling a prediction that does the thing. It's thinking about how else can we create efficiencies by just cleaning up and doing some housekeeping.
Cool. All right. Data engineering for NLP. I'm going to do this really, really quick in the interest of time because we are getting close here. First off, engineers ensure the availability of logical access paths to data stores for the business, whether that is our data science team or the business as a whole. Second, data engineers benefit from NLP metadata generated for complex unstructured data, right? We had some really great call outs there. Can we get to the title? Can we get to the topic? Who made it? Where was it made? When was it made? When was it last accessed? All of those pieces are very, very important to us, and our NLP friends are the ones that aggregate that. And last, data engineers are involved in each step of the NLP pipeline. And that is something that I've learned very, very well being at NM. And it's very exciting. Makes my day very interesting. We do have some NLP resources. Collins, in the interest of time, I think we're just going to flash those up on the screen, but you should be getting a PowerPoint. Do you want to give us some hot hits?
One second,
yes.
Shout out. So
yes.
These are all the click holes that I would go down if you're interested in just like what's happening in 2023, aside from the first one, which is just like an overlap or kind of a breakdown of OCR. But I wish I knew about medical NLP. I think that's a really cool field. It's super interesting, and it has a lot to do with what we've talked about. It just doesn't get talked about as much as like ChatGPT, but honestly leverages the same tech. So
yeah. And medical data and marrying up all those documents is wild. Talk about trying to find a golden record when you visit one clinic versus another clinic, and you need those records to marry up so you can go to your primary care physician. It's wild. There's a lot of research out there on it, so it's very cool stuff. Can I give a shout out to Rebel?
yeah, only if I can give a shout out to Layout LM.
Deal.
Right.
Okay. So Collins exposed me to Rebel, which is a NLP model that allows you to find entity records. So if you think of when you go to the library and you pull up a card record in the library of a particular material, it'll tell you the author was so and so. It was written in whatever. It was, the medium is vellum, it's calligraphy. And what this process does is actually identify relationships between all of those items. So it'll say, J.R.R. Tolkien is the author of Lord of the Rings, and so on and so forth. And this automatic metadata creation is very intriguing, and I've been having a lot of fun running all my homework through it. And Collins, Layout LM?
Yeah, so another quick 2-second piece. Layout LM is a really interesting thing because we talked a lot about documents that are images, and you could argue in a lot of situations the position of something on the page is just as meaningful as the words in order to determine what it is. Like, is this an address? Is this a company name? And knowing where it is on a page, as well as what words are in it. Those two things play together. Visual NLP is a big topic that's coming up a lot. Layout LM kind of touches on building a model that can encode the relationship between pixels and words, and attend to one another so that we can actually, do things like break up a receipt into metadata. It's super cool, and I feel like it's just being used more and more. So,
awesome. And with that, we're going to go ahead and open up with Q&A. Anything that we talked about today is fair game. Anything in general is fair game that you might like to ask. It doesn't necessarily need to be about the presentation. So yeah, we'll go ahead and open.
And I'll bring the microphone around to people who have questions.
Wonderful.
So
That sounds
those at home
great.
can listen. So who has a question?
I'll ask a question. All right, so Collins, I prepped you on this. Juli, I didn't.
Oh, no.
So both of you have expertise in your area, right? Can you give the students a little bit of background on what you studied to gain that expertise, whether it was in the university level or once you've graduated, just so they understand, like what an NLP scientist needs to look into or could look into, what a data engineer would want to look into?
Oh, no, you get to go first. You prepped.
I didn't actually come up with an answer. I don't know. My kind of academic trajectory has been all over the place. Like I didn't decide until way later what I wanted to do. So I did start out with a focus on linguistics. So that was really interesting to me. It had some intersection with NLP. So understanding like how we can logically represent sentences. And what kind of formal logics represent language at large, not just a specific language. So that was always interesting. And then it wasn't until later that I kind of got more into programming and statistics. That definitely helps. Statistics is good. And linear algebra. Trying to think what else. As far as like NLP stuff, it's tricky because it's niche. And I don't think they're, just like, I don't know, I think the best approach is just coming up with a project and like building it out. Because, I'm sure you have great resources here for faculty that can kind of guide that process, but building projects, reading academic papers, seeing what different companies are using for what, is a good approach. There's a ton of books if anyone wants references. The Stanford does their YouTube tutorial, or like not tutorials, but it's like YouTube lectures. And they have a computational linguistics one. It's super cool. The professor is really rad. He has a ton of great books. So,
Yeah. So on my side, I just as for background on this, I started in the mathematics program. That's what my undergrad is in. And I remember my senior year, we were working on a rather large project, and I stopped and asked my professor at the time, wait a second, how do they do this in the real world? Like, I don't get this. Like, does everyone just hand off spreadsheets? Like, this is very strange. And my professor's like, no. You would actually go ahead and use a database. You'd pull your data out. Everything would be consolidated and blessed and wonderful. And I was like, whoa, database what? And that's when I started diving into things. I have my master's in information science, and I specifically focused on the storage of data as well as application integration. In my PhD program right now, I'm specifically focusing on metadata for information retrieval. I really, really like distributed computing, so horizontal scalability, any sort of like upset to your system, we want to be ready for it so your databases never go down. But really a lot of my experience has been in the workplace, and a lot of my exposure and a lot of my learning has been in the workplace. And that kind of goes back to my idea of, shut your eyes, shut your mouth, open your ears, right? Is I don't care what role you are in, I want to hear about what you do and what your thoughts are and how you feel about this piece of technology. And that's really exposed me to a lot of awesome ideas and concepts and tools, and then just kind of taking that learning that's available either from that individual or from any sort of online resources. So, yeah.
All right, thank you. Other questions? I can skip my run today.
So what made you decide on your career paths? Like, what specifically was like, oh, that made me want to be a part of that?
Sorry.
Go.
Yeah, that's a good question. It took a while. I feel like it was just kind of realizing that there was a theme in all of the stuff that I kept kind of revisiting. And then, so starting with linguistics, doing a lot of like formal logic, actually, getting more into programming in the context of like art school, which was different. And just realizing like, okay, programming, linguistics, like these themes keep coming up. What's the relationship between them, and, what sort of opportunities are there to, kind of find a career that touches on these things that I, have a personal interest in. So, and I mean, that was like over a large span. So I guess one thing is like, if you don't know, like, I don't know, like the long game of like, like in 10 years, like you can just do a hard switch and you can move into a totally different career or a totally different field, take online classes, do whatever. So, yeah, I think just kind of, I don't know. I think there wasn't like an aha moment. It was just sort of, exposing myself to many different things and seeing what overlapped?
I think for me, it's two things. First, all I wanted to do was write code. I wanted to pick a role that would allow me to write the most code humanly possible. So I was really drawn to engineering because I saw right off the bat, I was like, oh my God, this is a lot of code. This is great. I like this. And I get a lot of exposure to different languages. I spend most of my day writing Python, but I've worked in R, I've worked in Ruby, I've worked in .NET, I've worked in SQL and MongoDB, everything under the sun. And being exposed to all those things made me very interested. I think then the other piece is just my desire for efficiency and also my love of cloud architecture. Most of my friends outside of work are site reliability engineers. Those individuals are responsible for making sure everything's running every day. So talking to those folks and going, wow, this is really cool stuff. Wow, this is really neat. I really like data. What can I do that's kind of like this? And that's where the engineering piece comes in.
Thank you. I actually have a kind of related question. So obviously when I asked Eric if we could have someone talk about, natural language processing or some sort of unstructured problem, largely because of what you referenced at the beginning, where that's not what people usually think about. But kind of broader picture, we have a lot of people here who I think are interested in this side of things. And we also have a lot of folks here who are double majors, like analytics and marketing or analytics and accounting or finance or whatnot. Can you just give us a really high level, where are some of the other areas in Northwestern Mutual where data mining, analytics, whatever is used to help support? So just so for students to start thinking about what sorts of what they would be doing in industry aside from potentially natural language processing.
Yeah, I mean, I am going to, it just feels right to hand it off to y'all. I feel like y'all can truly speak to the true, just everything there really is. Otherwise I'm happy to
That's cool.
Thank you.
Hi, everybody. I'm Angela Jorgensen. I'm our assistant director here for the compliance team that Collins and Juli are working on, and we're so thrilled to have them. So the question really is, what else can you do with this type of degree? Literally anything. We have at Northwestern Mutual, my team focuses in on the compliance space. We have all sorts of different departments within the company. Some of it's marketing, some of it's planning, some of it is sales practice focused, some of it's insurance, some of it's investments. But I think one of the great things about going into this type of degree is that flexibility. So Collins over on my team is focused on marketing materials, but we also have other areas where they're focused on medical records, right? So you could take that degree, do that here at Northwestern, you could do that over at any company, really. It's really versatile in the fact that that skill is needed in every single industry that I can think of. And we need people that are super interested in this type of analysis or engineering or technology or coding. And you blend that in with applying business pieces to it as well. I think I'm going to stop there. Yeah.
I was just going to add an add-on question to that, which is, we talked a lot about the engineering and the data science and how you guys work together. Can you share some of the other roles or responsibilities of folks that you work with on a daily or weekly basis that, you partner with to make the project successful?
I can hop into that. We kind of have a pod that we work with very heavily. Our data analyst on the particular project that Collins walked us through is responsible for making sure the business knows about our model. So he's very, very important because he is reflecting all of our hard work. We are also thankful to have an amazing project manager who is in charge of monitoring all the work that comes in, making sure we're not just doing work for no apparent reason. Everything has a purpose, as well as making sure that we don't walk into work and are just is like an onslaught of asks. So she's kind of like our frontline person. But what else?
I would just add that, David, responsible for knowing that our model exists, but also, he is the person that's building out, the application that they interface with. So, we can have all this great, structured data, but, our business partners aren't going to be wanting to use SQL. So, building out an application that, shows all of those analytics and shows all of that metadata that can help drive a business decision in a way that's like digestible to people who maybe don't have the same data literacy. So that's a huge part of it. I mean, yeah, I feel like, I'm trying to think what else. RPM, like.
Or business owners.
Yeah,
People
our
that
business
get our
partners,
model,
like that's a huge part is like, at the end of the day, like the people you're trying to build something out for are probably gonna take up most of your day as far as Zoom meetings, because you need to understand what they do, what's valuable to them, like what kind of like low-hanging fruit there is in their business process that can be potentially automated or just like, expedited. So we talk with a lot of people and work with a lot of people who kind of focus on different areas.
Yep.
And I could keep going, but we'll save time.
Just wanted to add one other thing as well, too. When we're talking about roles that involve data at Northwestern Mutual, I want to give a shout out to all of our application developers. So whether front end, mobile, or internal, they are basically a majority of the source of our data. So every decision they make as to what fields they're capturing, how they're formatting things, how they're providing stuff to us, they're a important group that we need to be integrated in with. So application development, that's a big one.
For sure. Because if you do have an application that's the source of your data, you may still have to do OCR, but at the end of the day, there's a lot of things that could just be solved by including a field.
Yep.
Maybe the thing you're trying to predict isn't actually recorded anywhere, and making sure that you understand the business process and have a relationship with the people that build that front end application, can just like totally save the day. And don't be hesitant to be like, oh, well, I'll make it work with the data I have. Like sometimes the painful process of being like, we don't have it, and how do we get it? And, even though it's a lot of work to integrate with an application, it might be a better use of time.
Cool. Are we wrapping up now? Just keeping an eye on time.
We have, for the people who are in this class, there's 15 more minutes. So
wonderful.
It's just going into our networking time a little bit. So if we have good questions, it's okay.
Absolutely. I'll save my closing till the end. I didn't want to.
All right. So what other questions do we have?
So we always tell the students in class that one of the biggest challenges for working with unstructured data, especially for supervised learning, is that data is not labeled. So first of all, what type of supervised learning tasks do you do on a daily basis, and how do you deal with that challenge?
Yeah, that's something I'm really glad you called that out, because that's a huge thing, right? Like these applications or business processes, were built out, and then we kind of come in and try to solve some sort of problem for them. That data that we need to solve the problem, as far as like a target to train on or optimize for, probably might not exist, at least in any kind of structured form that we can truly model. So unsupervised learning, like super important. In fact, like in the example I showed, the post-processing step from OCR, like we need to identify paragraphs in order to do semantic search. And we don't have that information. No one's, that's not labeled. We don't know where a disclosure is. We don't know if it's a disclosure. So, the approach to that is we used spatial clustering on the bounding box coordinates to, basically identify what is a, kind of a semantically grouped chunk of text. And that's super important, because if we try to do semantic search on like a sentence that's cut in half, that's not going to get us, that's going to be error that our model compounds. So there's so many different situations. In fact, like with the marketing materials, like we didn't have risk, right? We inferred risk. So what we did is we looked at the audit logs in the application to estimate the complexity and risk of a case, not undergoing the human review process. We used sample weights to penalize misclassifications on a separate target based on that inferred risk, and it got us closer. But at the end of the day, like this, we've actually incorporated a feedback form in the actual application itself, so we can actually have our reviewers say like, the model said it was this risky, it's actually this risky, and get closer to that true target. And the more that kind of happens and the more they interact with it, the more we have that data to like truly, solve the problem instead of working with like an inferred label. So that's like the biggest problem is all these systems weren't built out necessarily for data science or to be automated. So like huge parts, and I would say the majority of the pipeline, feels very unsupervised. There's also transfer learning. That's a really interesting one where you can take a model that was trained on a similar enough task, and then you can fine tune it on a small number of labeled examples that touch on your use case. And you also have this in-between step of domain adaptation. Maybe that like large language model doesn't really understand our business acronyms. So, maybe we want to do an unsupervised training task like, mass token prediction and next sentence prediction on our data to just get a little better representation of our vocabulary within a business. And then, train it on some data set for fine tuning or, whatever, and kind of work towards moving that model that was built for something very different closer to something that we can use. So, that's that. I mean, researching unsupervised approaches and going down those rabbit holes is super important because it's going to come up a lot.
All right. Thanks so much. Let's give them a big round of applause and then come on down.